Okay, good afternoon, good night almost. I'm going to try to explain you very shortly the main characteristics of the ellipse, which is the second conic section that we're going to see in our course. Well, first, I think most of you knows the ellipse. It looks like a squashed circle, so sometimes you can see an ellipse and it looks like a squash circle, something like that. Okay. The definition of the ellipse is it's a plane curve that the sums of the distance of each point of the curve in its periphery from two fixed points called foci are equal. So let me try to explain you. Oh, no. This is not going to be useful. I cannot move this. Wait a second. Okay. I'm sorry, guys. I'm learning. Well, I'm going to try to do a good ellipse. It's not going to be very, very good, but okay. Let's say that we have something like this. Okay. So in this ellipse, what we are going to have is 2 points, two important points that are called the foci. Let's say that we have our first foci and our second foci. Foci are always symmetric. So the distance between any of the points of the ellipse to each of the foci, or the sum of these two distances, is going to be the same in each part of the ellipse. So if we choose a point over here, the sum of the distance between this point and the first foci and this point and the second foci are going to be the same that the first two distances. And the same happens with any other point. So the distance between this point and this foci plus the distance between this point and this foci, it's always the same. So the sum of the distances of any of the points, it will be always a constant, the sum of the distance of any point to the two foci. Let's continue with the elements of an ellipse. So an ellipse, as the circle, has also a center, which is the middle point, in which this is the center of the ellipse, and it has two axes, okay? A major axis, that is this axis over here, the one that cut the ellipse in two pieces, and the minor axis, that is this axis over here, and size from this point to this point, okay? So this will be a minor axis. As you can see, the major axis is bigger than the minor axis. Well, besides the center and the axis, we have already talked about foci, which are 2 points, always on the major axis. Another thing that you must know is the major axis will be always equals to 2a, and the minor axis will be always equals to 2b. And the distance between foci and foci, so this distance, it will always be equals to 2c. So when we can know, let me rewrite it in order to be clear, is the distance between the center of the ellipse and the any point of the major axis is going to be a. Okay, so this distance is going to be a, and the distance of the sum of the two a's is going to be the major axis, which is 2a. The minor axis will be always 2b, and the distance between the two foci is going to be always 2c. The equation of an ellipse, which is not with a center in the origin, is going to be x minus h squared over a squared plus y minus k squared over b squared equals to 1. So the equation of the ellipse, as you can see, it's kind of different from the equation of the circle. And this is a horizontal ellipse because the A value is the half of the major axis. So, for example, if we have an equation which is x minus 2 squared over 25 plus y plus 3 squared over 9 equals 1, you will have to know that the center, it's at 2 comma negative 3, that it has a major axis of 10 and a minor axis of length is 6. How did we know that? Because 25 is a squared. So if a squared is 25, the value of a will be 5. And 9, it is equals to b squared. So b squared equals to 9. So b will be 3. So half of the major axis is 5 and half of the minor axis is 3. Let's try to sketch a graph. Well, first, let's talk about the vertical ellipse. Basically, the equation is the same. The only difference is that you will have a bigger number just under the y value, and the minor axis will be just under the x value. So for example, in this case, this part over here is going to be b because it is half of the minor axis, and this part over here is going to be a. And the foci in this vertical ellipse is going to be on the major axis. So this is going to be the first foci, and this is going to be the second foci. Finally, I want to tell you a very important rule, which is the Pythagorean relation between A, B, and C. So A squared is going to be always equal to the sum of B plus C. And remember that A, it is equals to the semi or half of the major axis. B, it is always going to be the semi or half of the minor axis. And C, it is going to be half of the distance between the two foci. Half of the distances between foci. Okay, I know that from at this moment this could be a little bit overwhelming, but don't worry about it because this is the first time that you are sketching an ellipse. So don't worry, we're going to work in a lot of exercises of an ellipse, but let's do our first exercise. So first thing you have to do is obtain the center of the ellipse. And the center is basically the same as a circle. It is h, comma k. So in this case, h is 2 and k it is negative 3. So the center of this ellipse will be at 2, comma negative 3. And to express that, let me try increasing the size of this sketch, of this graph. Okay, I think this is going to be okay. Okay, so center is going to be 2 comma negative 3. So at 2 comma negative 3, negative 1, negative 2, negative 3, in this point we will have our center. Okay, that is the center. Then we have that a squared, it is equals to 9. So a will be the square root of 9, which is 3. And we also know that b squared, it is equals to 4. So b is going to be the square root of 4, which is 2. So from the center, I'm going to move 1, 2, 3 points or 3 units to the left, to the right, and 1, 2, 3 units to the left in order to mark my major axis, okay? And what about the minor axis? Minor axis is going to be 2 units on the center and 2 units down the center. So this is going to be my minor axis. So my ellipse will be something like this. I'm sorry, please, for the sketch, but I hope you have understood this. Okay? The other thing that I can ask you is where are the foci? And for doing that, or to know that, we have to apply the equation, the Pythagorean equation, which is a squared equals to b squared plus c squared. So we're looking for the value of c. Again, a squared will be equal to b squared plus c squared. So in this previous exercise, the value of a squared is 9, the value of b squared is 4, and we can solve for c squared. So c squared will be 9 minus 4. So c is going to be, well, c squared is going to be 5, and then c is going to be the square root of 5. So in our previous example, we will find that the foci is square root of 5 far away from the center. And more or less, the square root of 5 is 2 point something, okay? I don't know, 2.2, 2.3. But that is before the major axis. Well, I hope you have understand something about this video and you could take a note. I see you tomorrow in class.